Hello, people. This is Teacher Calvin, and welcome to another episode of Science I Can Do. And with our great tips, I'm sure science you can do too. Today, you're going to be watching a video conferencing lesson on the topic of cycles with regard to cycles in matter and water. So, sit back, relax, and enjoy the lesson.
Okay, good. All right. All right. The diagram shows the change of a substance. All right. Right. So what do we have here? Well, solid. What do we know? Ice is a solid, right? People, ice is a solid, right? Yes. And what happens? What's the process of A? How did ice become water?
It gain heat.
Yeah, it gains heat and melt, right? Yeah, melt,
Yeah.
right? Yeah, because it gains heat. Very good. So we learn all the stuff like revision. So how does water become like water vapor? It gains heat again, right? To boil, right? Arisa, understand? Right? It boils, okay? Gains heat again. All right? But you see, when all this water vapor rises up to the sky, where the mountain is, what happened to them? They lose heat, right? Drop in heat, right? Guys, girls, understand what I mean? Like we have a sea here, then the sun shines on them, right? It heats up the water vapor start to rise, right? Okay. When they reach like the top of the mountain, okay, they form back into clouds, the water vapor. So this is what's happening. The loose heat and what? What's the name of the word? Rex, do you know what's the name of the word? What happens here? Condense, D-E-N-S-E. Okay, condensation happens here. Understand or not? Okay, condenses into liquid. People understand? It condenses back into liquid. Get it? Hello? Which is like the clouds. The clouds are liquid, no? People understand? Condensation and then liquid. Come on, who can tell me? Rex, how does liquid become back into solid? Change the gas, water vapor condenses back into liquid, like forming clouds. From clouds, clouds become liquid, and then liquid, how does it become back to solid? You put the water in the freezer, Rex. What do they do? What's the name of the word?
Freeze.
Yes. Who said that?
Sophia. Me.
Okay, which ones in that case correctly represent A, B, C, D? Can everybody find me the answer then? I think I've given you the answer. What's the answer, everybody?
Freeze.
Three, Carissa said three. Let me check. Everybody agree that it's three. A is melting. Yes, that's what I wrote there as well. B is boiling. Yes, that's what I wrote there as well. C is condensation. Yes, and freezing. Okay. Okay. Yellow. Okay. There, number 3 is the correct answer. Yeah, Carissa, so clever. Let's move on. Okay, can. All right, Mr. Singh. Use force setup WXYZ in the table as shown below. He wanted to find out how the temperature of water affects the rate of evaporation. Temperature of water, right, affecting the rate of evaporation. Okay, what do you think, people? The higher the temperature, the higher the rate of evaporation or lower? Use your brain. Don't even have to see the experiment. Higher the temperature will be higher the rate of evaporation. Rate means how fast. Can you see? Hello? Girl, understand? Evaporation. Okay, I already given you. What else affect rate of evaporation? Come on, just revision. Anyone want to tell me? What else affect the rate of evaporation? This is not just pertaining to a question. I want to know what else affect the rate of evaporation. Anyone? Carissa?
Exposed surface area.
Yes, exposed surface
Okay.
area. Okay, that's why you see your mother, when they hang out the clothes, they don't leave it in like a lump like that, right? She'll open them up. This clothing dry faster than this clothing. Do you understand? Because you don't, this one no exposed surface area, very little. Can you understand? Sophia, understand or not? Sophia, don't play with the video. Pay attention. So the higher the temperature, the faster the rate of evaporation, the bigger the exposed surface area, the more the evaporation. Anyone? Anyone? Use your brain. How do you dry your clothes faster? See, as I go about rate of evaporation, I teach you all about the topic, not just from one question. Come on, Carissa, want to tell them? Carissa seem to know. Sophia knocked out already. How about wind? The more wind on a windy day, right? Your clothes get dry faster, right? The higher the wind, the better the evaporation. Okay, I have short form now. Do you understand? That's why you need the wind. You know why the wind can increase your rate of evaporation, Carissa? Do you know that? Do you know that? Why? Because you see, on top of your clothing, they are like water molecule trying to escape. So they escape into the air here, you know, that was your clothing. They escape into the air here, and then the wind will carry all the water particles away. Then they become dry again. So it's easy for the rest of the water molecule on the surface of the clothing to come out. Can you see? Because no jam there, you know, like MRT, when you jam there, they cannot come out. Okay, that brings us to humidity. Humidity. Okay, humidity means how wet it is. So after a raining day, you don't need to hang out your clothes. Why? Your clothes will not get dry. Why? Because there's a lot of already water vapor in the air. Do you understand? Get it or right? Totally saturated. That means full of it. So how can this guy want to jump out into the air? Because it's already full, like jam already. Do you understand? Say, Carissa, do you understand what I'm saying?
Yeah.
Because the air already full of water vapor. The guy say, I want to come out. I say, no need lah. Stay inside there. We are packed already, like the MRT train, no, the train is full. You don't need to come out. That's why it's slower to evaporate on a day after raining. Do you understand? Because the air is very humid. Get it? Huh? All right. The more humidity you have, the less is your rate of evaporation. Okay. Okay. No space. I just spread that. Can I? All right. Come. In this case, let's come back to this question. So I'm not doing a question with you. Just very good, happy. Just move on. No, I'm explaining a whole concept with you. Can you see, Carissa? In case you forgot about it.
I haven't learned water cycle.
Can you see the wind and humidity? Can? Okay. So
I
let's
never
start.
know water cycle.
You haven't learned, then you learn now, lor. Better still, I teach you already the evaporation, condensation. Okay, that's why you learn here. All right, we have a mixed bag here. We learn everything here. Never mind. As long as you pay attention, you learn. Hey, I like your clap. Who clap? Okay, okay. Volume of water. Okay, 100, 100, 100. See, everybody started 100. Temperature of the room. See, this is like room temperature. Can you see? 28. This one is like air conditioned room. Can you see? 20. Can you see? So very cold. Okay, so very different. And see, people, the rest, okay, maybe like these are hot. right? Okay. Oh, Sophia, pay attention, eh? So, yeah, this is so cool.
I
Can you see?
am.
Temperature of water 40, 40, 60, 60. Exposed surface area 100, 100, 200. Which two setup we should use to ensure a fair test? Come on, which one do you think? You want to see temperature. So temperature can change. The rest cannot change. Which one can pick? How's the temperature of the water affects the rate of evaporation? Okay, so you must find the experiment that the temperature can change, but the other condition cannot change. So which is it? Temperature must change, people. So which one can be the answer?
Number 4.
Number 4. Number 4, Y and Z, right? Okay. All right. You want to test the temperature affecting the rate of evaporation. The water must remain the same when you start your experiment. Then the temperature of water. Okay, temperature of water must change. Okay, temperature of room cannot change. Very good. So temperature of water change. They're different. Very good. And then surface area must remain the same. Yes. Very good. In that case, what do you expect? What is the result? What do you expect? Y or Z will have more water or less water left? Miss Carissa, since you tell me this, Y or Z will have more water left after a while. So there, they have the same beaker. After a while, you see water will evaporate, right? Which one you expect to have less water? Carissa?
E.
A, Y or Z? Where got B?
Z.
Oh, Z. Oh, okay. Z will have less water. Okay, you call it Z. All right, fine, no problem. Why, people? Why? Because this is 60 degrees. Can you see no? Hotter. Hotter temperature will evaporate faster. I told you already. Okay, this one like little bit only because this is only 40 degrees. Can you see, huh?
Thanks for watching. And if you like what you see, do give us a thumbs up, share, and subscribe. And for more great tips like this, be sure to watch Science I Can Do.